focuses on transformations, which is of both shapes on an axis and of graphs in general. First question just kind of explores the basic methods of transformation. So here we have a reflection in this line M. So here we have to do is think about those points and think about how they change as you map them onto the line. This point is already on the line, so they don't change. This one, you have to go 3 to the line, so you just continue and go 3 more. Same with this one, 1, 2, 3, you go 3 more. So now you've got your 4 points, and yeah, you have to pretty much just join them. So you just join these two, these two, and these two. And this is basically a shape. Obviously, you use a ruler in the exam. This one is pretty much, it's an enlargement. So usually with an enlargement of more than one, such as 2 or 3, you'd go up to there, for example, 4 squares, and if it's 2, you'd double that, and you'd go 4 more, as in 8 in total. But here we've got half, so instead you do the opposite. 4 here, so you go only up to 2. 4, I guess 4 here, 4 up, so you'd go 2 there and 2 up. And here you go 6 and then 4, so you'd go 3 and then 2. So you can kind of see how it resembles the shape of this triangle, and basically just fill in those lines. And yeah, that's basically your new enlarged triangle. It focuses on rotation. So with rotation, kind of depends on, obviously you could just kind of imagine how it moves, and that might be enough for something like this, where you might think it's somewhere about here, maybe it's this point, maybe it's this point, maybe it's somewhere even like around the origin or something along those lines. If you kind of try and imagine it, maybe you might think that it's this point. You'd be correct. But realistically, there's also a more solid method that you can do it. You could kind of imagine points. You could also, if you joined up 2 points, for example, here, actually, let's use the same color. So if we joined up, for example, these 2 points, the corresponding points, they have to be corresponding. Obviously, this point is the same as this point. And same with this one, for example, if we joined up this tip to this tip. So now, obviously, I'm sure you know how to do perpendicular bisectors. So in the exam, you'd use your compass and ruler, but here I'll just fill them in. So I'm just going to go in just diagonally. The blue ones are the perpendicular bisectors. And pretty much when you do the 2 perpendicular bisectors of these joined lines, they will meet at some point. I've drawn this a bit badly, but in reality they meet here at 3, 1. So that's how you'd know that that's the center of rotation. You pick 2 points. Obviously, if they meet, if the perpendicular bisectors are the same, okay, the same line, you have to pick another point where the perpendicular bisector is different, because then it could be any number of points. But in this case, pick 2 that have different ones, and you can kind of tell it's a bit off, but they do actually meet at 3, 1 if you did this with a ruler and compass. That's how you know that it's basically a rotation about this point 3, 1. And in terms of angle, well, you can probably imagine that it's 90 degrees, because, for example, if you imagine it, if you just reflected it, rotated it along this point, you pretty much just get something along this line. Maybe like, say, F dash, and this would be the reflected point. So obviously this is the right orientation. It's just a little bit off in terms of it being 1 squared for 2 left and 2 high as well. So that's what it would be. Just a rotation about 3, 1. Or maybe you could specify 90-degree rotation, 3, 1, and I'll specify that it's a clockwise rotation. So clockwise. Or I guess you could say 90 degrees clockwise rotation about 3, 1. So this one is pretty much just the 4th type of transformation, which in this case is a translation that wasn't covered in the previous section. This is probably the easiest of the few, since it's pretty straightforward. What we have to really do here is, for example, pick a point. Let's then pick this corner point. and think about what happens to it. So these shapes are obviously the same orientation, that helps. Since there's no rotation, reflection is just a translation. And you have to think about what happens to it. So in the PQ vector form, the P symbolizes movement in the x-axis and Q in the y-axis. So it might just be easy to think about what happens to it first in the x-axis. So this is the corresponding point that it rotates to, this one. So to get from here to there, you need to move here, which is 5. 5 in the positive x. You go from 2 to 7. So I guess plus 5 in the x-axis. And in here, you're going from 5 to 0. So you're going that way down. So I guess it's minus 5. So really what's happening here is P is 5 and Q is minus 5. That's your translation. It's actually quite difficult and can get quite confusing in terms of keeping track of all your transformations. So it's pretty much just time to get started. So you start off with a rotation of 90 degrees clockwise about the origin. So first, I want to think about how would you go about doing that. First, for example, map it from 90 degrees onto there. Where would you imagine the first point to be? So I think a good approach is to kind of draw almost a hook that attaches itself. So we might use something like red to make it more distinct. So it goes from here to here. So I'm saying from this point to the origin, which is our center of rotation. So, and then we think about rotating this hook 90 degrees. So if you kind of think about rotating 90 degrees, you'd move along there, and then you'd end up just having a clockwise hook. And this corresponds to this point. So if you thought about doing the same, so say you had one over there, you'd be rotating it. And you pretty much end up having it be just one below. And this part would pretty much just be where you'd expect it to be in the triangle. If these are the two legs, then this one would just be 2 apart from them. This would be the triangle. So, and then it's followed by a reflection in the line x equals 3. So I want to give a think, what is the line x equals 3? Imagining what happens as you move it along. So that's basically your shape after the first reflection. So now you have to think about what x equals 3 means. Is it a line that goes like this? Is it a line that goes through here? Or is it maybe a diagonal line that crosses 3 somewhere? If you thought that it's this line, you'd be correct. Because what it means is x is equal to 3. So x is equal to 3, and it would just go vertically through x is equal to 3. So you have this line that goes over here, obviously along x equals 3. And now you just have the reflection. So we've already kind of done this. You take the point, this one is already on there, here, to there, and to there, and same with this, to there, and to there. So you pretty much just draw your shape. So now this is our new shape. This is our shape B. So that's basically much the first part of the question completed. So now we have to think about T. So to do T, we already know the end product and we know the first transformation. We need to just know the second transformation. So we'll start off with drawing y equals minus x. So what exactly is y equals minus x? Is it maybe this line? It goes to the origin. Is it maybe something different? If you thought it was something a little bit different, you'd be correct. So it's sort of similar to y equals x, which is what I just drew, where each point is the exact same, but just reflected the other way. Y equals minus x. So let's say x is 1, and y has to be minus 1. So it would be over here. It's pretty much the same thing, except that it just goes this way. So along the origin, but something along this idea. So as you can see, it's a little bit raw, but you kind of get the general idea. That's basically what it is. That's the line. And now we have to think about a reflection in that line. So again, if we kind of think about what happened before, we trace our steps. So we start from here and we go 1, 2, 3, 4, 4 up to here. So now we don't just keep going that way because obviously it's tilted at 45 degrees. So we'd pretty much just follow the tilt. So we go down instead. You can kind of think of it as being reflected. So then you go 1, 2, 3, 4. And drop a point there. And you go from here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the same for this final point 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now you pretty much have your triangle. But we're not finished yet. This is our triangle, and then we do transformation t to it. We don't know what t is though, but we know that using t, we get it to be. So I think it's really easy to tell that it's already the correct orientation. It looks pretty much exactly the same. Nothing needs to be turned or rotated. Nothing needs to be flipped via reflection. All we need to really do here is just a simple translation. So it's already, they line up in terms of the axes. So this point is already on the same y-axis, -3, this one's on -4. So what we have to do is modify the x-axis. So let's say we pick this point. How many steps do we have to go? 1, 2, 3, 4, 5, 6 to get to that back point. Try it with this point. 1, 2, 3, 4, 5, 6. So it needs to go 6 in the forward x direction, from -1 to 5. From -3 to 3. 6 in that direction. So what that represents is pretty much just write that down as translation via vector. And then obviously we have 6, 0. We just revisit enlargements. So the last time we kind of did 1/2. In this case, we're doing it of something that's more than 1. So they've already given us currently 7, 3, the point marked with an X, so we just get started. So you kind of went over it already. Translations basically just, enlargements basically just go from one point to a point and keep going in that direction. So we might as well just do that to the points. So if we think about, let's say, this innermost point, we have to move 4 over here. So we basically just move 4 again since it's a scale factor 2, which would mean we need a movement of 8 in total. So 4 here and 4 there will give us a number here. So if we think about this furthermost point, we'd be going 4 and then 2, which is 6, and we have to go 6 more. So 2 and 4. And maybe we could do one more point. So let's say this top corner point. We move 4 and 2, so that's 6 and 3. So we've already moved 6 there, so all we need to do is move 6 up here. So from here you can pretty much just sketch the rest of the shape. Here you'd be going 1, but instead you'd go 2, because obviously it's scale factor 2. Here you'd usually be going down 2, but here you just go down 4, because obviously it's scale factor 2, and this one you go down 2, kind of makes sense. So, and now you pretty much just sketch the shape. So, use my drawing abilities. It would look something along these lines. And this would be our shape Q. So the second one is just a reflection, sorry, a rotation. So again, we can kind of use this idea of this connection. In this case, it's just a line. And if we think about rotating this 90 degrees anti-clockwise, obviously a clock goes like that. Anti-clockwise would just mean going like that, so sort of along this axis. So 90 degrees anti-clockwise would basically just end up be 90 degrees over here. This would correspond to this top point. If we did this again, but we used this point, it would just end up 2 lower. And from here we can pretty much sketch the rest of the shape, because this is the line. Erase these lines. This is corresponding to this line, and everything's rotated 90 degrees. So you'd end up just having this line at the bottom with the 3 points. And then you just have the one going up, the one going here, and the rest of the shape. So you'd end up just having something along these lines. So if you imagine this rotating 90 degrees, then obviously you think you'd end up with a shape somewhat looking along this line, but instead it's kind of shifted down because obviously center of rotation is quite far away. So this would be a final shape, and we'll just label that one R. That's pretty much this question.